Hello, this is going to mostly be a video for review for our quiz coming up, but this video is going to be over all of factoring polynomials. So it's not going to be super long, but I'm just going to kind of pick the examples that cover all the different things that we've learned, okay? So, you can watch this as many times as you want, rewind, fast forward to what you need. If you have a question, just let me know and we can, go over stuff a little bit more, but okay, so what are all the things? All right, number one, factoring out a GCF. All right, you have to know how to factoring out a GCF. So if you have a polynomial and you don't have that constant at the end, which means that every single one of your terms has an a value in it, you want to factor out a GCF, all right? So looking at the numbers here, we've got 12 and 10, all right? 12 and 10, their common factor is 2, so we're going to pull out a 2, but then we're also going to pull out an a. And so what do we have left? 12 divided by 2 is 6, and then we have 1a there, and then 10 divided by 2 is 5. So this would give us 2a times 6a plus 5, all right? And that's it, so it's already factored. So that's kind of easy, if you have that situation. Another situation that we looked at is difference of squares, okay? And the rule for the difference of squares is that if you have two perfect squares and they're being subtracted, like a squared minus b squared, it's always going to factor into a minus b and a plus b, okay? Because a times a gives you a squared, and then b times negative b gives you negative b squared, all right? And so for this example, all right, we have 64x squared. So what do we want our first two parentheses to be? We want it to be 8x and 8x, because 8 times 8 is 64. And then our b squared is negative 49. So that means we're going to have plus 7 and minus 7, all right? And this works for any time you have two things that are like this. Remember, 1 is a perfect square as well. So like on this example, where you don't have a number out in front, you could just do like x squared times x squared. So that's difference of squares. Difference of cubes, it's a little bit trickier. There's just basically a rule that you have to follow. You need to know what a and b are, and in order to do that, you need to know your perfect cubes. So for this first one, we have 8m cubed, right? So 8m, actually, I don't really want to do this question. I want to do, whatever, we'll just do this one. Okay. So what is a? So a is actually going to be 2m, all right, because 2 cubed is 8, and then you have the m because you need it to be m cubed. And then for b, it's going to be 6n, because 6 times 6 times 6 is 216. So then you want to take your a and b, and you need to put it into your formula. So it's going to start with a plus b. So we're going to have 2m plus 6n. Okay. And then you've got a squared. So it's going to be 4m squared minus a times b. That's going to be 12mn. And then plus b squared, which is going to be 36n squared. And so that's how you would factor this. And that's just your answer right there. So I'll give you this on the test. You just need to know, how to find a and b and kind of plug them in. So that's the rule for sum of cubes, all right? The rule for difference of cubes is pretty much the same thing, all right, except the formula is a little bit different. So you still want to figure out, what's a and b. So here, a is going to be 6k because that cubed will give us this. And then b is going to be 5 because b cubed is 125. So now, again, we want to plug these in. So we first got a minus b, so that's going to be 6k minus 5. And then we've got a squared, which is going to be 36k squared, plus ab, so multiply those together, that's 30k. And then plus b squared, that'll be plus 25. All right, and that's how you would factor this one. So this is all the binomial stuff. Okay, difference of cubes, sum of cubes, difference of squares. All right, the next thing we did was we did trinomials, and we're going to go over two trinomials, one with a quartic and one with a cubic. All right, so these are both solved similarly to how we did normal quadratics. All right, you just have to remember that Now we have n to the fourth as our leading term and n squared in the middle. So when you factor it, instead of doing like x and x, you're actually going to do x squared and x squared, or in this case, n squared and n squared. All right, but you factor it the same way as just a normal quadratic. You want to find, what multiplies to make c and adds to make b, right? And so for this case, that is plus 6 and minus 4, okay? Because 6 times negative 4 is negative 24, 6 minus 4 is 2. So this would be how you would factor this problem, just with the n squareds in there. Now the cubic, all right, the cubic is a little bit different. You're still going to end up factoring it the same way, but first you have to factor out a GCF first. So if you notice, all of these terms have an a. So we're going to pull out an a, and we're also going to pull out a 7 just because we can. So that's going to leave us a squared, 53 divided by, wait, can we? Oh, wait, we can't pull out a 7. My bad. 53 is not divisible by 7. So we can only pull out the a. Never mind. But regardless, this brings us into a normal quadratic there. So we just leave the a out in front, don't worry about it unless you're solving. So because our first a value is a 7, we know we're going to have like 7a and a. And so we want to think about what multiplies to make 28. Well, there's a couple things, but one obvious one that jumps out to me is 7 and 4. So if I put 7 and 4 in here, remember now I want to check, okay, this would make 49a, this would make 4a. Do those add up to 53? Yes, okay. So that would be the answer to this one. It would be a, 7a plus 4, and then a plus 7, all right? So that's how you do a cubic, all right? And then the last one that we learned this week is factoring by grouping, okay? And that one's a little bit different. This you use when you have 4 terms, okay? And when you're doing factoring by grouping, you're going to follow these same steps every single time. The first thing you're going to do is you're going to group your first 2 terms together, and you're going to group your second 2 terms together. So you got 2 groups here, and then you're going to pull out the GCF of each group. So for this first parentheses, I'm going to pull out an x squared, and inside the parentheses, that's going to leave me with x plus 1. For my second parentheses, I'm going to pull out a minus 4, and that's also going to leave me with x plus 1. So if you do this correctly, you should always get 2 parentheses that are the same, okay? And now this last step is a little bit tricky, but once you do it a couple times, you'll start to get it. The answer is x squared minus 4 times x plus 1. Okay, now where did that come from? Well, the x squared minus 4 parentheses, this came from our 2 GCFs, okay? So whatever things you pulled out in front, they kind of come together to make your first parentheses. And then our second parentheses was just those 2 parentheses from above that were the same, all right? So this polynomial up here, this one up here, it factors down to x squared minus 4 and then times x plus 1. And so that's kind of what you would do for each of these. So like I said, this was just a quick rundown over all the methods, just in case you needed like reminding. If you want help or you have more in-depth questions, go ahead and shoot me a message and I'll get back to you. Good luck studying. I know you'll do well, and have a great day.